Greeting and welcome, friends. Today we're talking about solving equations with some multi-steps here. Yeah, that's right. Today's the day where we're combining all the punches, kicks, blocks, roundhouses, backflips, full Nelsons. Oh, it's all coming together. It's going to be wonderful because our Pokemon are going to evolve and learn some new moves. I'm so pumped. So here we go. It says solve the following. Now, you might notice I've got this thing here where the 2 is on kind of like the outside of parentheses. What mathematical operation is going on here? Like, what's going on between the 2 and this parentheses? Multiplication. And it turns out we were just practicing with my buddy, my personal friend. I'm actually his mentor. You'd be surprised. You would have thought he was my mentor, but that's not the case. Sal Khan. And Khan was talking to us about distribution and what we can do when I'm multiplying a number by a set of parentheses, a sum or a difference. I can distribute there. So I've got to actually multiply everybody in the parentheses by 2. So what's 2 times 1? Not a trick. That's 2. And 2 times negative x, if it helps, you could think about that as negative 1x. 2 times negative 1 is negative 2, except that's got an x with it. Oh, wait a minute, guys. I forgot. Does this 3 need to be distributed? No. 3 is not getting multiplied because it's outside the parentheses, right, friendly friends? Is this negative 8 being distributed to? Also no, because that's like not even on the same side of the equal sign. So plus 3 equals negative 8. Now, before I start trying to solve for x, let's simplify further by combining like terms. So who are friends here that want to hang out with each other? This 2 and this 3. Why can't I combine the negative 2x with them? Oh, it's not a like term because that's got a variable. I like it, man. I like it. I'm going to write my variable expression, my term first. So I'm going to write that as negative 2x. And what's 2 plus 3? That's 5 equals negative 8 still hanging out. All right, so now we've brought it back to the same as a 2-step problem that we would have seen yesterday. Okay, so I distributed, I combined like terms, and now I'm going to solve normal style. What should I do first? Minus 5, both sides. Now, if you told me, well, Mr. Waddy, I want to divide both sides by negative 2, you are allowed to do that, but that's going to make things, ugh. Look at that, ugh. Oh, man. It'd make, like, gross fractions over here. Usually students don't like fractions very much. But I like the idea. Let's SADMEP it. Let's deal with the addition, subtraction before we deal with the multiplication. And the inverse of adding 5 is subtracting 5 from both sides. Also, both sides is always referring to both sides of the equal sign. I would not be allowed to, for instance, like just write minus 5 on the same side. That's subtracting 10 from one side. Okay? So let's see. So negative 2x, these 5's cancel out, equal negative 8 and negative 5 combined to be more negative. Negative 13. And then, okay, this is a negative 2, so do I add 2 to both sides? No. Yeah, the operation that's taking place is multiplication by negative 2. So that's not subtracting by 2. So to get rid of that, I've got to do the inverse of multiplying, which is divide both sides by negative 2. I didn't say it was going to equal 8. No, it's negative 2x is equal to negative 13. Here, we'll see. I'll show you in the check. So notice dividing by negative 2 does in fact result in x being left by its lonesome. Here those negatives cancel out. I'm going to leave this as 13 halves. And improper fractions are awesome. Okay? Unless this was like a word problem, I wouldn't ever tell someone I ran 13 halves miles today. One, I would never run that far. But also because in units, you would rather say I ran 6.5 or 6.5 miles, right? You do a decimal or a mixed fraction. But in algebra, we're actually going to leave ours as reduced improper fractions unless the original problem had decimals or unless the problem was a word problem. All right, but let's do a check, because you said this isn't equal to -8, but behold, check, 2 minus 2, instead of x, I'm going to plug in this thing, 13 halves plus 3, is that equal to -8? Now, is that one that you guys could have guessed the answer to? No, I don't think so. Also, I'm missing parentheses, aren't I? Oh, guys, no. I plugged it in here. This is actually a really good example. I plugged this in here. What if I do this whole thing and it works out just fine? The only thing I've checked is whether it's true from this point on. I need to check it in the original problem. I don't have enough undos to get me there. Oh dear, my apologies. Although it's actually much easier if I was plugging it in there. My apologies, friends. 2 times 1 minus 13 halves plus 3 equals -8. How many think that's going to be true? I have no idea. I hope it's true. I believe the algebra worked out, if I didn't make any mistakes. But as you've seen, I've already made some. 1 minus 13 halves. Kind of don't want to take a lot of time to get a common denominator. Here, you guys can just blur your eyes over this for a minute. I'm just going to get a common denominator and rewrite that as 2 times 2 halves minus 13 halves. Don't fret too much about that right now. If you need help with getting adding, subtracting fractions, Khan can help you out with that. It's not going to show up a lot in our course. It will sometimes. But right today, I want to talk about algebra a lot more than that. So 2 halves minus 13 halves is -11 halves. Anyone think this is going to turn out to be true yet? All right. I always like how my 11 in a numerator kind of looks like this awesome little smiley guy. Yeah, that's all right. Pretty awesome. Happy. So let's see. Notice this, when I multiply those, how cool is that? These 2's cancel out. -11 plus 3, is that equal to -8? It is. It works. So guys, notice this problem, that would have taken me a super long time to guess and check my way to a solution. But using algebra, I distributed, I combined like terms, I subtracted 5 from both sides, divided both sides. I actually was able to get the answer pretty quickly, way faster than guessing would have for a problem of this complexity. All right? All right. Let's take a look at monitoring progress questions 4 and 5, which are the very next things in your packet. And let's do these together. I'm going to do this a little quicker. All right. Ready? I want to solve this equation. Don't worry, I'll find a lot of reasons for you later. The rest of this course is one reason, but there are real-life applications as well. So let's see. Here we go. To solve for x, 3 is being multiplied by this set of parentheses. To simplify, I'm going to distribute. So 3x plus 3, because 1 times 3 is 3. This 6, notice, did not get distributed to because they were outside the parentheses, equals -9. Meow? 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 All right, all I've done is distribute so far. Questions on the distribution step. I've multiplied. What's the next thing I can do? Add 3 and 6. Why? Because those are like terms. All right, so I'm going to have 3x. What's 3 plus 6? Yeah, that's 9 equals negative 9. I'm trying to keep my equal signs lined up, not doing the best job at it, but want to keep my work organized. All right, how do I get x by itself? I agree. Now, in this case, guess what? If someone told me divide by 3, why is this problem actually okay to divide by 3? Wow, man, right there. Seriously, don't even, you guys should just unsubscribe from Wadi Math. You need to subscribe to Kaylin Math on YouTube. She just told us why dividing works just fine. Because all these terms, 3x, 9, and negative 9, are divisible by 3. That dividing by 3 is actually not that painful. Usually, dividing before adding or subtracting would create fractions, but not bad. But in this case, we'll just follow the normal route. Yeah, that became more negative. Now what do I do? Divide by 3. There we go. X equals negative 6. I like it. Let's have you guys take a look. What do you think? No, I'll do one more, and then I'll have you guys do 6, 7. You can like not pay attention when I'm doing it and see if you could speed ahead. Question? I don't know, 5 years ago or something, 6 years ago. Oh yeah, absolutely. All right, so guys, this problem up here. Oh, do I have to multiply this 5 by all of these? No. I'm multiplying the 4. Only the thing that's on the outside of the parentheses is getting multiplied. And actually, it's not even a bad idea to be attentive to what sign this is. I wouldn't make a mistake when it's positive, but if that was subtracting, it's easy to forget to distribute the negative. All right, so I'm going to distribute here. So I'll have 15 equals 5. 4 times 2d is 8d, so plus 8d. And 4 times negative 3? 4 times negative 3. Negative 12. We ready to combine like terms? Let's combine some like terms. Oh, here we go. Can I combine these? Why not? Those are like terms, guys. But you told me they're the same. What? No, but yeah. You gotta go check out Jake Math on YouTube. He just told me these are on different sides of the equal sign. I can't combine them like that. But what can I combine? Yeah, those are both constants. They are like each other. I can combine those. So 15 equals, I'm going to write the variable term first, 8d. And 5 minus 12 is, negative 7. All right? What do you guys think I do next? Would dividing by 8 be okay this time? It'd be awful. Ugh. It would just create the worst fractions, right? So let's add 7 to both sides. So Ben, let's see. 15 plus 7 is 22 equals 8d, and those 7's canceled out. All right, you're definitely getting the algebra. How are the rest of us doing? So let's see. So I'll get, in this case, I'm not going to leave that as 22/8. I can think of something that could reduce that. How'd you get that? All right, so yeah, divide each of those by 2, right? 2 goes into 22 11 times, and 2 goes into 8 4 times. And instead of 11/4 equals d, I'll write d equals 11/4. Look, there's another great numerator, 11 on top of the fraction bar. Good stuff. All right. So internet friends, I'm going to have my real life friends here try problems 6 and 7. And you can feel free to scrub through the video ahead until you see me start writing something. But I'm going to walk around the room and hang out with my real life friends. There we go. I'm seeing some mathing, but not a lot. All right, so let's see. Start question 6 by distributing this -2. So 13 equals -2y. And careful, calculus students will make this mistake. Remember that negative sign is going with it. -2 times -4 is +8 plus 3y. Keep going from there. All right, Ben, what could I combine up here? Yeah. What can I combine, Ben? What are your thoughts? Can I combine this and that? They're on different sides of the equal sign. If they were hanging out on the same side, then I'd be able to, but that's okay. Oh, that's weird. They have to be on the same side. But I can combine these two because they're both y's. All right, so let's see. I'm going to have 13 equals -2y plus 3y is 1y, which you could write 1y or just plain old y, yeah. And then plus 8 is still hanging out there. How do I get y by itself? Subtract 8 from both sides, and I'll get 5 equals y, or better yet, y equals 5. All right. Now we're going to practice this again tonight. We'll practice similar problems again the next day, except adding one more layer of complexity, right? Preparing you for that algebra boss fight. Here we go. Let's see. I'm going to do this one speedy so I can get to example 3. 2x times 5 is 10x. 2x times negative 3 is negative 6x. So look at this. This x got carried through to each of those. You see that? But the numbers in front was just a result of 2 times 5 and 2 times negative 3. Oh, guys, this is so cool. Look at all these like terms. They're all friends. 10x and negative 6x and negative 3x. They're all buds. So let's see. 10 minus 6 is 4. 4 minus 3 is 1. I get 1x, or better yet, x equals 5. Go, not bad. All right, we got to take a look at example 4. Oh, you're doing example 4? I just want to make sure you're ready to like do your homework tonight. Ooh. All right, use the table to find the number of miles X you need to bike on Friday so that the mean number of miles biked per day is 5. This is actually a problem similar to one that we looked at last week. Let's see. So the first thing I'm going to do is just define my variable. What does X represent? What's the problem tell us? Yeah, so number of miles. Let's see. I'll just call it Friday miles. Okay. What's an equation I could write? Well, let's see. What do they say? They want the mean number of miles. Okay? So I'm going to take this information. And how do I find a mean? Yeah, number of them. You could describe that as quantity. How many there are. Quantity. There we go. All right. Yeah, there we go. Look at that fraction bar. So my equation is going to look like this. You ready? I'm going to put my variable first, but you could technically write it in any order. I'm going to write x plus, and then I just need to add all of these other things to it, right? I'll just do the whole thing backwards. 5 plus 0 plus 5.5 plus 3.5. And then I divide by how many there are. How many are there? All right, there's 5 separate ones there, including my yet to be determined one, so I'm dividing by 5. And what do I want that equal to? I want the mean to be what? Yeah, 5. I want the total average to be 5. All right, so there's my equation. I had to pull in some previously known information, right? I had to gather these facts from around this problem, and now I'm going to solve this. I think I'm going to simplify by combining like terms first. Look at this. 5 plus 0 plus 5.5. Yes. Yes, that is another way you could solve it. Yeah, we'll talk about that after I combine these like terms. 5.5 plus 3.5 is 9. 9 plus 0 is still 9. 9 plus 5 is 14. And Kalen Math said, don't I just need the stuff on the top to add to 25? Actually, wait, I don't know an answer yet. So guys, if I want to solve this equation for x, what do I have to do to both sides? Should I subtract 14? Why can't I do that? Because this is like trapped in the numerator of this fraction. I have to deal with this 5 first. Oh dear. Oh, double dear. Oh, I'm still not zoomed in enough. There we go. That's good. How do I get rid of this dividing by 5? Don't guess it. Algebra it. Algebra it. So watch, multiplying both sides by 5. Whoa, man, my mouse is going crazy. You got, what's going on? I'm scared. Well, it's not about the answer, it's about the method now. So these 5s cancel out. I get x plus 14 equals 25, which is what your intuition told you earlier, Kaylin, right? Yeah, you said the stuff on top has to add to be 25, and that's where that came from. Now, how do I get x by itself? Minus 14 from both sides. Now, I realize you might have been able to guess that answer, but your answer guessing strategy only works when problems are easy. No, I'm training you on simple enemies so that you'll be ready for the big boss fight later. So my answer is you need to bike 11 miles on Friday. I don't think they're going to make it. Not that I'm like not believing in them, but when I look at the average they've got so far, I don't think they're going to make it. Do you guys agree with that, Ben Trinley? Yeah. I mean, like, if you look at their average so far, 11 is going to be such an outlier for them. They're going to have to work really hard to make that happen. Maybe they are. Yeah, maybe they are. All right, well, thanks for watching, Internet friends. Have a great day.